What we have is data on performance in the decathlon. The decathlon has 10 events. There's the 10 events, 100 meters down to 1,500 meters. What I wanted to do is to find the correlation between pairs of events. Some of these events will require the same athletic skills, in which case you'll have a high correlation between those two events. Here is, I'll just close this off. Here is the data. It's in an Excel file. So this is the 100 meters. I think this is the long jump, so on. It's a 1,500 meters. This is how different athletes performed in those 10 events. The first step I did was to change the labels of the variables to their actual. So I edited this file and changed it into this one. Here I put, rather than X1 up to X10, I put the names of the different events. So here is my SPSS. I'll open it up. So I will want to read in the data. I'll open up a file. Okay, the file type is an Excel file. So I go, it's on the desktop, so I search for it. This first one here is the original file. It's the one that has the labels for the events as X1 up to X10. This one here is the one that has the labels. Actually, the labels of the events in the first row. So that's the one that I'll open up. See, it has the labels of the different events in there. Press OK. And there is the data. These are performers. These are their different outcomes of the different events. So I asked you to correlate them. To do this, you go Analyze, Correlate, Bivariate Correlation. And then all you do is select the variables that you want in there. 100 meters, long jump. Actually, I could have selected all of them and put them in there. So that's put all of the 10 events in there. And then all you do is press OK. And there it has a table. This is the advantage of having the variables labeled the way they are. It becomes easier to read. Correlation of the 100 meters with the long jump is 0.55. Correlation 100 meters with the shot put, 0.281, and so on. So what I've done is actually put it into an Excel file. This is the Excel file. I've taken away the stars. Here, what I'm going to do is try to set up a table where I have two events and then the correlation that's related to those two events. Now, Here, this is going to, I'm using some techniques in Excel. If previous column was 10, I will simply go to the next row, add it by 1. Otherwise, I'll stay in the same row. Similarly here, if the previous column was 10, then I'm going to the column will be the row plus 1. So there's 2 formulas. If I copy them down, and I can do that by just selecting these 2 and pulling this thing down. There I'm up to row 4. I want row 9 to be the last one. Yeah. So I'm getting the ones above and below. Then I'm going to use another technique in Excel. To read off. So here, I'm going to read off the row label. So I use the offset function here. This is the G2 is the base cell. And then to read off the offset, I'll go down 1 row if it's a 1, down 2 rows if it's 2, down 3 rows. And then here I'll read off the column label. So again, using this, I won't go down any rows, but I'll go across this number of columns to read off. And then the final one is reading off the value. Again, I use this as the base. I'll move down 1 row if it's 1, and across to the correct column. So then all I can do is pull this in and copy these formulas down. And that will give me a table giving me 2 events and the correlation between the 2 events. Now, I will then copy this table and just paste its values here. Okay, then I want to see which ones were the highest correlations, which ones were the lowest. So I just sort by correlation. From highest to lowest. Data sort, highest to lowest. So there we get the event which has the highest correlation. That's between the shot put and the discus. Next highest correlation is between the 100 meters and the 400 meters. Here is a summary of the date of the calculations. There is the table of correlations. To read this a little bit better, go across here. Here I've sorted the correlations from highest to lowest. I think the ones where there's a high correlation are of interest. And below here, these are the ones with the lowest correlations. The lowest correlations are with the 1500 meters. 1500 meters requires the quality of endurance. The ones with the high correlations, you can see why they are. Discus and shot put, these are upper body strength. 100 meters and 400 meters, that's running ability. Short distance running ability, probably leg strength. 100 meters and long jump. Again, in order to perform well in the long jump, you have to be able to run fast. Okay, you have to have good running speed. So that's why there's a correlation there. Long jump in the hurdles, you're jumping as well as running. I should have put the line separating. These are the ones with low correlations. I should have put the line separating those two. After shot put and javelin, these are the ones with low correlations. They're of interest as well. Mainly, it's with the 1500 meters. That event is the one that is that is least correlated with the other events. So at that point, we'll stop and I'll answer any questions.
Hi, I just had a quick question about the table that's generated. So for the assignment, when we submit it, do you want the table that is just generated by SPSS, or do you want it as a list like you did in Excel there?
Okay, I just like I did it as a list because when I did it that way, I thought that would be the best way to present what's in this table here is with this table where the correlations are going from highest to lowest, because what's of interest is what events are highly correlated, why they're highly correlated. Obviously, the highest correlation was shot put and discus, and you don't see that in this big table here. Now, I'm very good at Excel, so I was able to get formulas that allowed you to get this list of highest versus lowest. Okay. And then, yeah. So I will accept probably any sort of input. I'm just encouraging people to try and put it in the best possible form, to learn to write so that everything is as clear as possible. Now, in actual fact, there are advanced statistical techniques. One of them is called principal components analysis. Another one is called factor analysis, where they're trying to find linear combinations of the variables that are most highly correlated. So in this way, you can interpret these linear combinations, one measuring arm strength, one measuring leg strength and leg speed, another one measuring probably endurance. The 1500 meters is really endurance, and it's the one that's least correlated with most of the other events. Anyway. So I will accept any sort of output. Quite often in statistics, there's a variety of how things can be shown, and no one method is better than the other method. This is the one that's containing the table that SPSS puts out. I've eliminated a lot of the rows. A lot of the rows are giving you information that we don't, at this point, are not interested in. We're just interested in the size of the correlations.
Okay, thank you.
Mhm. So are there any other questions?
Yeah, so for our submission then, are you just wanting us to use that, like that small graph that you generated with the R values in it? Are you wanting us to compute that basically and then include that in our final submission only?
Sure, yeah. That would be fine.
Okay.
Mhm. I think in this one here, if this is the graph, the chart that is given, this is what's put out by SPSS. You might go through the chart and pick out the ones where there's the highest correlation.
Sorry, do you mind sharing your screen?
Okay. So I was saying with this graph, you can, this is a bit too overwhelming, okay? But if you look through, you'd see the highest correlation was between two events that both involve arm strength, shot put, and the discus. They also possibly involve leg strength as well. Then lower correlations, and they're still pretty high, are obvious when you convert all of this to this table. This table here is the same as this table, except we're ordering the correlations from smallest to largest. And the largest correlations are of interest, but also the low correlations are also of interest because those are events. 1,500 meters an event that's has a low correlation with the other events. It involves running endurance, not involved in the 110 meters and other events. So this is one way of displaying the data. This is an equivalent way of displaying the data. What we've done is pick the ones with the highest correlation, the ones with the lowest correlation, and left out the ones that were in between. Anyway.
Hi, do we have to submit it as an Excel file or a Word doc?
I think a Word document, in a Word document, it is in a form that the markers can read. Okay. So in a Word document, or you can convert the Word document to a PDF. That's also something that the markers can read.
Excuse me, you probably went through this already, but I missed the first half of the class, like the first 2 minutes. But
Sure.
what do you do when you get the correlation on SPSS?
To get the correlation on SPSS, let me just open up SPSS again. Okay, no. Let me just minimize this, minimize this, minimize this. This is the Excel file that contains the data. There's the data. The first thing I did was get rid of these labels and get the actual labels. And I saved that in another Excel file. That was in this one here. So this is the same file, except I put the labels of the events there. So now I have that data in there. Now I have to open up SPSS on my computer. This is SPSS.
What did you change the labels to?
To the actual, like they were, the labels of the columns were X1, X2 up to X10. It's more better to put the actual labels of the events, 100 meters, long jump,
Okay, great.
distance, you know. So I'll open up that file. Okay, it's an Excel file, so I have to wait, no. So then I go and search for it. It's this one here. This is the one with the labels changed. Press OK. I don't know. I don't know if it did. Open data. Cell. That's the one I want to open. I open it up. Okay, I think the reason it's not opening it up is because it's already. It's already opened up, so Excel, SPSS didn't like that. No. Okay, so here it is. I'll open up a file. It's an Excel file. And then I search for it. It's on the desktop. It's this one here. Press open. There's what it looks like. That's correct. Press OK. Okay, so these are different performers. This is their performance on the 100 meters, probably in seconds. Long jump, in meters, shot put, meters. Okay, so then I want you to find the correlation between these variables. So you go to correlate, bivariate. You select the variables that you want to correlate. If there's more than two, it'll do all of the correlations between every pair. So there's the variables. Press OK, and it will do all of the correlations between every pair. So this is a table. this is Pearson's correlation coefficient. This is, we'll learn about this later on. This is for testing whether the correlation is 0 or not. This is the probability of getting a value that large. If the correlation is 0, this is the sample size. So what I then did is get rid of the stars. The stars are, you double star if the probability of getting a value that large is less than 0.01. Single star if it's less than 0.05, but not less than 0.01. So then I basically formed this table. Here, this is the table that's in Excel, but it's got a lot of the rows deleted. It's got the stars deleted from the values, the double stars. And then this here, I've formed a table where it'll pick off from row 1, column 2, picks off the label for row 1, the label for column 2, and it picks off the correlation. You could do those all by hand. What I've done is use some Excel formulas. This one, I use the offset formula. It's useful for looking up data that's in a table. The basis is this cell here, G2, and this is how many rows you should change. 1 to move down to here. This is how many columns you should change to pick off the value 0.585. So the next one, it picks off from row 1 and column 3. Row 1, column 3, it picks off this number here, 0.281.
Sorry, did you copy the table in SPSS into Excel, or you entered it by hand?
No, I copied it and first of all pasted it into Word. And then from Word, I got rid of the double stars and the stars and then put it into Excel. So it treated everything as numbers. I could have copied it from here.
So we go from SPSS to Word and get rid of the starred numbers.
Yeah, that's what I did. So for instance, here, I can just edit. Copy, I think. Edit, copy. And then in an Excel file, maybe not this one. I can paste it into an Excel file. I can get rid of this column because I don't want these 2 columns. I got rid of those, got rid of that all the way down. And then to get rid of the stars and the double stars, that's a hard thing to do. Um, you can do that with a formula. For instance, here equals left. This value here, the length I'm going to go is 4, because that will get the dot, 5, 8, and 5. So that gets rid of the stars here. But I also have to do something like convert it to a number. It's still, so I think the Excel function there is value. So that converted it to a number. Got rid of the stars. Now, if I pull that all along, that does it for all of them. And then you can do it downwards. The problem is I should have gotten rid of these lines there. But you have to, in order to sort them according to magnitude, this is now considered as a text in Excel entry. And so it won't sort them according to magnitude, right? Anyway, those you could do by hand, possibly. Just go in and put these numbers in by hand without the stars in them. What I did do is I used Word too. Let me do a new document, blank document. There's the table. I'll copy it. I'll go into Word and paste it. There it is. Now it's got stars and double stars, but then all you have to do is I'll start up here.
It asks.
I'll just go and here home, replace. I'll replace a double star. Actually, a single star will work with a space, with nothing. Replace all. Wait a second. No. I think you have to select it all and get it. I don't know why it didn't do anything. Anyway, it's tricky. Edit, replace all.
I think it didn't do anything because that's an up arrow, not an asterisk.
Okay, so replace all. That, yeah, that did it. See, it replaced it, all the double stars.
Sorry, when you copy it, you get the whole table as what it was in SPSS. But when I copy it, I just get some random numbers all over the place.
Okay, I'm not sure why that's the case. Okay, I think you in SPSS. Where is this? There's the table. No, that's the data. There's the table. If you double click on that, you can then edit. Copy, and then I go to Word.
For this assignment, we'll need to download Word.
Possibly, okay. You don't have Word. You can, if you have another word processing package.
You could probably use Google Docs if you don't have Word.
Yeah, that's probably. No. I'm trying to.
After you double click on the table, you just copy it.
You just copy the table and then you can paste it into Word. Okay,
I
here's
don't
Word.
let me do that. When I copy it, I just get the numbers. I don't get the whole table.
Okay. Okay, so I copied it, I pasted it, and it pasted it into a Word document.
I think that's because you're using the web-based Word, which doesn't have all those features of like the Word that
No,
Yeah.
it's the Word app.
Mhm. Yeah. I'll paste it as formatted text. There it is. Now I could copy this and paste it into Excel. I'll open up a new one. That pasted into Excel. Then from that, I get rid of the lines that I don't want. I don't want those two ones. Delete. I don't want those two ones. I also don't want, just use control. So I get rid of the ones that I don't want. And I don't know if I can get rid of the double star and the single star by doing just I'll select that, go to home. replace star with nothing. But I think when it says replace whatever you find. Okay, so that didn't work. I think you have to go into Word to do that editing. The only reason I got rid of this double star and star is I wanted to sort the correlations in that one table from highest to lowest.
I'm so sorry to ask you this again, but do you mind just showing me how you copied it? Because I just want to know if I'm missing anything.
Okay, well, here is let me just go back to the data. I don't know if I'm in SPSS. I think, no, I'm in Excel, I think here. So this is
Word.
This is Word, so I get rid of it. I'll get rid of this as well.
Do we have to use Word?
You don't know, you can use any sort of thing that you want. Okay, this is Excel. This is the data set. This is the output. There is the correlations. If you double click that, you get here, you can then select the table. You can then copy it. Then you can copy it and paste it into Excel or Word. I'll paste it into Word. This is an old document, so I'll just get a new blank document. There's the blank document, and then I'm just going to do Control V. It pastes it into Word.
This is how I get it. I don't get the whole table. I just get them like in the Word document.
Yeah, see, this is the whole table. 100-meter long jump, shot put, high jump, 400 meters, 110 meters hurdle. Discus is the 7th one. The next one is long jump. No, wait a second. No. I'm not sure what's happening here. I'll Control Z. I'll stop that and go home. Paste. Paste special. Okay. Now this, I'll paste it into here, there it works out. And when you paste it into Excel, it works out nicely.
So
The trouble,
copied the whole
trouble is this is black, so I want to change that to no fill. Now, what I would do is get rid of the rows that I don't want, this one here, together with these two, together with these two, these two. These two, these two. Anyway, you get rid of the rows you don't want. You can possibly then copy the graph, the chart, and paste it into Word. You get rid of the stars that way. Anyway, this lecture I've recorded, so I don't know if I record it, does everybody have access to the recording? Anyway, right now I'll stop sharing and we'll now end the lecture.